Dear students, let us now discuss few more examples from friction chapter from the same book, that is by R.K. Rajput, Engineering Mechanics by R.K. Rajput. So in this example 6.7, okay, as you can see in this figure, an object of weight 100 Newton is kept in position on a plane inclined at 30 degree to the horizontal by the applied force P. The coefficient of friction of the surface of the inclined plane is 0.25. Determine the minimum magnitude of the force. The force in this case is horizontal, okay, which is shown over here, P force, and you have an object weight is going the direction of the weight force is downwards. Okay, so let us understand the free body diagram of this object. So you have horizontal force P. You can derive two components of this force, one in along the plane, along the inclined plane, and other is perpendicular to the inclined plane. Then similarly the force W, again you can divide it into or find two components of for it. One is perpendicular to the plane, which is W cos alpha, because alpha is the angle of the plane, so you get over here, and W sin alpha, okay, is a component which is parallel to the inclined plane. Okay, so we can determine the we have to determine the magnitude of this force P. Okay, and let us see the solution for this. So here resolving all the forces that we have already did, resolving all the forces parallel and perpendicular to the plane, you have parallel to the plane Wn force, because Wn force is the friction force, because the object is considered to be moving downwards. So mu n plus P cos 30 degree should be equal to W sin alpha. Okay, so this is one equation. The second equation is n is equal to W cos alpha plus P sin 30. So we get these two equations, which are so there are two unknowns. One is alpha, and the other one is P force. So we can resolve these two. So alpha is given to be 30 degrees, sorry. So this second equation is like this, and by putting the relevant because n is unknown, so we can replace n force from these two equations, and the remaining equations will give us the P, okay, force P. Okay, so this is given over here. After solving, you get this. Let us now move to the next problem. Here the problem statement is like this: a flywheel of radius 40 centimeters supported on a bracket and rotating about an axis O. Okay, so this is the rotating wheel is brake by means of a lever as shown in the figure 6.22. The force applied at A is 15 Newton. Sorry, 150 Newton. It is misspelling here. Okay, corrections here. So if the coefficient of the kinetic friction between the flywheel and the brake shoe is 0.3, what braking moment will be applied on the wheel with respect to the axis? Okay, so in this you have this wheel which is at a distance of 60 centimeter from the wall, and you have this lever is total 180 centimeter long, and on the end of it at point A you have a force of P is equal to 150 Newton. Now how we have to solve this equation or this problem is we will find out the total friction force over here, considering that n is the reaction at this shoe, between the shoe and the wheel. Okay, so the total friction force will be F is equal to mu into n, where mu is the coefficient of friction. Okay, Then you have the we can consider the moment of this force friction, this normal reaction, okay, and which is between the shoe and the wheel, and this P is equal to 150 Newton force about point B. Okay, so these two things will provide us two equations that we can use to solve our problem. So radius of the wheel is 40 centimeter, it is given. Okay, so radius of the wheel is 40 centimeter. We have to find out the braking force required. Okay, so braking, so effort applied at point A is 150 Newton, mu is 0.3. Now taking moment about point B, okay, which is at the wall, this wall. So we will get this normal reaction into 60, and then that should be equal to 150 into 180, because 180 is the total distance. Okay, so n comes out to be 450. Now because n is 450, you can find out the friction force between the wheel and the shoe, which is 0.3 into 45, which is 135. Braking moment to be applied is 135 into R. So 135 is the friction force, and R is the radius of the wheel. So this is the total braking moment required, 135 into R. So this is 5400 Newton centimeter. Okay, coming on to the next problem, which is example 6.10. It is a ladder friction problem. So in this ladder, we will not solve this problem, but just discuss it briefly, because solution is already there in the book that you can refer to. A ladder 5 meter long and of 250 Newton weight is placed against a vertical wall in a position where its inclination to the vertical is 30 degree. Inclination to the vertical is 30 degree. A man weighing 800 Newton climbs the ladder. At what position will he induce slipping? Okay, the coefficient of friction for both the contact surfaces of the ladder is with the wall and the floor is 0.2. Okay, now in this you see you have the friction force here. There is one normal reaction at point A, okay, because this ladder is AB, and then you have some normal reaction over here. Now the ladder is going to slip, that means it is going to move in the leftward direction if it has the tendency to slip, because a man is standing on the ladder at a distance from distance of x from this end A, and there is a force or weight of the ladder which is also considered to be at the acting at the CG or center point. So this force, considering that Na is the reaction of the vertical, you can see the vertical reaction at point A, which is vertical, and F mu A into Na is the friction force acting in the direction towards the wall. Okay, and here you have reaction NB, and there is a, because ladder has the tendency to come down, the force will be, friction force will be acting upwards, which is mu B into NB. Now we will solve this question by taking the resolution of the forces along horizontal direction, resolution of the forces about the vertical direction, and moment about a point, which you can take point A, because there are two forces which are going through it, so you don't have to calculate the moment for these two forces, because they will be passing through A, and hence their moment will be zero. So you have the horizontal components of the forces which are acting on the ladder, that is NB, then mu A and A, and okay, and these are the two forces which are acting so on the ladder. So you have this equation, okay, and then you have the another equation in which you resolve all the vertical forces. So this friction force, then force of this ladder, force due to this weight of the man, okay, and then this reaction force. So total four forces. Okay, so this comes over here, okay, sorry, this okay, and then you can find out the moment about point A, and accordingly you can find out the value of x, which is the unknown over here. Okay, so this is about these problems. Okay, thank you.